Cyber threats, they're getting smarter every single day. Like, scary smart. So the big question is, can our defenses actually keep up? Well, today we're going to dive into a new kind of AI that's not just some simple security guard. No, think of it more like a super smart detective for our entire digital lives. All right, let's jump right in.
Okay, so at the very heart of how we all stay safe online, there's this thing called a network intrusion detection system, or NIDS for short. I want you to picture it as the bouncer at the front door of your network, right? It's that frontline defense, constantly checking IDs, watching everyone who comes and goes, just looking for any sign of trouble.
And believe me, this job is absolutely critical. We're talking about protecting everything from the gigantic servers that run Google and Amazon all the way down to your own company's most sensitive private data. NIDs are basically the digital burglar alarms for all of it. They're always on, always scanning traffic, looking for those telltale signs, the digital fingerprints of a known attack. And when they spot one, the alarm bells start ringing, loud and clear.
But here's the catch. There's a huge problem. These old-school security guards, well, they're starting to get seriously outsmarted. The sheer volume of data flying around today is just staggering, and the attacks themselves are getting so much more clever. The traditional ways of doing things, they're really struggling to keep up. So let's break down exactly why.
So the biggest issue with the older models, it's a real bottleneck. They need a human to literally sit down and manually tell them exactly what a threat is supposed to look like. This whole process is called feature engineering, and it's a huge pain. It's slow, it's super easy to make a mistake, and honestly, in today's world, it just can't keep pace. But this new deep learning approach, it flips the script completely. It actually learns what's important all by itself.
And look, this isn't just me saying it's a problem. The researchers who built this new model put it perfectly. They call this manual stage a time-consuming and error-prone process. And in the world of cybersecurity, error-prone, well, that can lead to some really, really bad days.
Okay, so this is where things get really cool. This is the big innovation. Researchers developed a model that is way more than just a simple alarm system. It learns, it remembers, and it knows how to focus on what's truly important. Kind of like a seasoned detective on a high-stakes case who knows exactly which clue to follow.
So the first secret ingredient is something called long short-term memory, or LSTM. Now, the name sounds complicated, but the idea is actually pretty simple. It gives our AI detective a memory. So instead of just seeing one-off, isolated events, it remembers the entire sequence of what happened. It can connect the dots over time to spot those really sneaky, complex attack patterns that a normal system would totally miss.
And then there's the second piece, which might be my favorite part, the attention mechanism. This is literally our detective's superpower. Think about it. There's a flood, an absolute sea of data pouring in every second. This mechanism lets the AI pay attention. It can zero in on the most suspicious bits of data and just ignore all the background noise. It's all about finding that needle in a massive haystack.
And this is what it looks like when you put it all together in what they call the LSTM model. You see, the data comes in and first hits that LSTM layer. That's where it gets the memory, the context. Then, the attention layer kicks in and acts like a spotlight, highlighting the most critical pieces of information from that sequence. It's this powerful one-two punch of memory and focus that makes it so special.
But here is the real game changer, the biggest advantage of all this. Remember that slow, difficult manual feature engineering thing we talked about? Gone. This model does it all automatically. It learns what's important by looking directly at the raw data. And that means it's faster, it can adapt to new threats on the fly, and yeah, it has the potential to be way, way more accurate.
Of course, a clever design is great and all, but it doesn't mean a thing if it doesn't actually work, right? The proof is always in the pudding. So the researchers decided to put their new creation to the test. They threw it into the ring against a super tough industry-standard benchmark to really see what it was made of.
And they did not go easy on it. They used what's called the UNSW NB15 dataset. And let me tell you, this thing is an absolute monster. It's basically the ultimate obstacle course for any security system. It's packed with a huge mix of normal, everyday traffic and count them, 9 different kinds of modern cyber attacks. We're talking more than 250,000 data samples in total. It really is the perfect gauntlet to run this model through.
So, the big question, how did it do? Well, after all that, the LSTM model came out with an accuracy of, drumroll please, 92.2%. Now that is a seriously impressive number. But to really get a feel for just how good that is, we need to see how it stacks up against the competition.
Because look, context is everything, right? 92.2% sounds good, but what does it really mean? Well, check this out. When you put it side by side with other state-of-the-art models that were tested on the exact same dataset, it's not even close. It is the clear winner. I mean, it's beating some of them by more than 15 percentage points. That is a huge leap forward.
So let's dig a little deeper. What does that 92.2% accuracy actually look like in practice? This chart here, called a confusion matrix, gives us the nitty-gritty details. Out of more than 175,000 different scenarios it was tested on, it correctly flagged almost 118,000 normal events as safe, and correctly spotted over 44,000 attacks. So it's not just getting a good grade overall. It's actually really good at its two most important jobs, letting the good guys in and keeping the bad guys out.
And this is way more than just a cool result in a research paper. No. This kind of performance signals a real, tangible shift in how we can approach cyber defense. This is the kind of technology that can make all of our digital lives a whole lot safer.
So let's bring it all home. What's the big takeaway for you and me? Well, it means smarter defenses that can catch the kinds of complex threats that older systems just can't see. It means our security can adapt to brand new attacks way faster. And maybe most importantly for the folks on the front lines, it means way fewer false alarms so they can focus their energy on the real dangers. At the end of the day, this is the kind of research that builds a safer, more secure internet for every single one of us. Which kind of leaves us with one big, fascinating question, doesn't it? We're building these incredibly intelligent AI defenders, these digital detectives. But cybersecurity is a constant arms race, a relentless cat and mouse game. So as our defenses get this smart, what kind of next-level, super sophisticated cyber threats are being designed right now to try and outsmart them?